Today's lesson is on 3.5, but before we go to your 3.5 notes, you're actually going to start on your Chapter 3 postulate paper and add a couple more theorems and postulates that you will need for this lesson. First, you have the parallel postulate. The parallel postulate says, through a point not on a line, there is one and only one line parallel to the given line. That's a really fancy way of saying, if I want to draw a line through point A that's parallel to my original line, there's only one existing line that would be through point A and also parallel to the original line. There's not two lines, there's not three lines that fit the description, only one line fits a description of through point A and parallel to the original. Next one. Triangle angle sum theorem. This is actually one of the most useful theorems you learn the whole semester. You use this a ton for the rest of the year. The triangle angle sum theorem says that the sum of the measures of the angles of a triangle is at 180 degrees, always, no matter what type of triangle it is. So that's a conclusion you want to add in. The total of those three corners, the total of those three angles, will be 180. Here's a quick visual demonstration of why that works. If I take each of those corners and I drag them together, including the top one, I just flipped the top one upside down. Together, they make a straight line. And that's true with any triangle. If I cut off the corners and put them together, they'll always make a straight line when I face the corners towards each other. All right, now we're going to apply that theorem in particular to solving the first couple problems on your notes. So go to your 3.5 notes. Question 1. Well, you know, for any triangle, the sum of those interior angles will be 180. So you're going to start just by saying x plus 25 plus 90 has to equal 180. Go ahead and solve. You added your like terms. You subtracted 115 from both sides. You got 65 degrees. Try question 2. For question 2, it starts off the same. A quick note, you'll often see this with angle problems. When you have a longer expression with a plus or minus sign as your equation for an angle, they'll often put it in parentheses to say the degree symbol applies to the whole thing. So there's nothing really important about the parentheses in this case. There's nothing outside the parentheses you're distributing. So usually when I rewrite it, I ignore the parentheses. I just write 5x plus 12 and then plus 6x plus 3x. Then you added your like terms. 5x, 6x, and 3x were like terms. Added up to 14x. And then you worked to get x by itself. You subtracted 12 from both sides, and then you divided by 14. You're doing the same process with question 3. It's just now your expressions have fractions in them. Go ahead and try question 3. So your starting equation should look like this. You can kind of ignore the parentheses. They're optional if there's nothing outside of them, the parentheses being distributed. Now you want to add your like terms. Your like terms, there's 3 and minus 3. Oh, that's cool. They cancel out. 3 minus 3 will cancel out and get 0. And then the s's, there's 1 over 7 here, 1 over 7 here, and 1s here, invisible 1 coefficient. So you add that up, and that's 1 and 2/7 s equals 180. Now here's my tip. I highly recommend with problems like this, you rewrite that coefficient as an improper fraction instead of a mixed number. Remember that process? Front number 1 times the number under the fraction and then add to the top. So you could rewrite that 1 and 2/7 as 9/7. Now, when you have a fraction coefficient, the easiest way to cancel it out is to multiply by the reciprocal. What is the reciprocal of 9 over 7? If you multiply both sides by that reciprocal, it cancels out the original coefficient. And when you do 180 times 7 over 9, you get as equals 140. Question 4. There's 3 different variables to solve for in this one, and some are easier to solve for first than others. I recommend you solve for x first, and that you do so by highlighting the edges of the triangle x is part of. So to solve for x, look at the corners of the small triangle it's part of. Those 3 corners should add up to 180. Add your like terms, and then get x by itself. Now, once you know the answer to one variable, sometimes it helps to add it to the picture. So I would recommend writing a little 54 by the x here, because that might help you solve for y. Because if you look at where y is, y makes a straight line with x. Go ahead and solve for y. So we know that x plus y make a straight line. In other words, they equal 180 because they're a linear pair. So if x is really 54, you could solve for y and get y has to be 126. I recommend anything you figure out you add to the picture, so maybe write a little 126 by the y on your diagram. And now solve for z. I recommend highlighting the triangle z is in and going from there. For z, y was really 126. So z plus 126 plus 19 would equal 180 for that triangle. You added the like terms, and then you worked to get z by itself. There's 2 definitions you're going to write down on the back page of your notes. The first is an exterior angle and what that is. An exterior angle is any angle you create outside of a triangle by extending one side. If I just take this side of the triangle and extend it further, that creates this exterior angle. Remember, exterior is really just a fancy word for outside. So it's an angle outside of your triangle instead of inside. Next definition, write this down. Remote interior angles are the 2 interior or inside angles that are farthest away from your exterior angle. On the diagram above your definitions, go ahead and label those angles in the picture, the exterior angle and these 2 remote interior angles. Remote, if you think about it, in everyday English, really does mean far away. When people ask the hypothetical question, what is the one thing you want with you if you were stranded on a remote desert island? It means an island far away from everything else. Or television remote, it lets you change channels when you're far away from the TV. So remote interior angles, the name literally tells you it's the interior or inside angles that are farthest away from the exterior angle. So not the interior angle right next door to the exterior angle, but the 2 further away. Those 2 definitions are especially important because now you're going to go back to your Postlet paper for Chapter 3, and there's a theorem all about interior and exterior angles called the triangle exterior angle theorem. So this is back on your Postlet paper. This theorem says that the measure of each exterior angle is equal to the sum of the measures of its 2 remote interior angles. In other words, if I'm trying to solve for an exterior angle, I could just find the sum of the 2 interior angles farthest away. That's your conclusion. Write that down. X would have to equal 80 plus 60, or in other words, 140 degrees. This theorem provides an excellent shortcut for problems like number 5. All you have to do was say, if x is an exterior angle, I just add the remote interior angles. X would equal 17 plus 32. X equals 49. Try number 6. This one's interesting. This time the exterior angle has an answer, but you could still say it's equal to the sum of the remote interior angles. So you could say adding x plus 30 should equal 80. So x would have to equal 50. Try number 7. You're solving for angle 2 here. The remote angle is 48.3. You could say it's the sum of the exterior angle is 48.3. You could say it's the sum of the remote interior angles. So your equation could look like that. Measure of angle 2 plus 26.8 should equal that exterior angle. For number 8, I recommend you start solving for x first. It might help to highlight the triangle it's part of. So those 3 triangle corners have to add up to equal 180. You should get x equals 113. Now solve for y. I want to point out there's actually 2 different ways you could solve for y. You could use the linear parable, or you could say y is an exterior angle for that green triangle and use that shortcut. For y, either way, you should get y equals 67. Just a quick note, if you treat y as the exterior angle of the green triangle, you just add 28 and 39. That's all. Now solve for z. Now that you know that y is really 67, you could say z plus 64 plus 67 equals 180 for that left triangle. Add your like terms and isolate z. Z equals 49.